All right. This is from Adekunle Ajasin University Akungba, Akoko. But the year for this particular post-UTME is omitted, so I cannot place clearly which year. But question 2 of that particular year is what stated. It says solve the equation 4 raised to power 2x minus 5 into 4 raised to power x plus 4. You see that that's also similar to some of the other either one or two of the institutions that we have solved before. It's still the same approach. So we have 4 raised to power 2x minus 5 into 4 raised to power x plus 4 equal to 0. So this under exponential equation. So our duty is to rewrite this in terms of 4 raised to power x. So this is going to be the same thing as 4 raised to power x, 4 raised to power 2 minus 5 into 4 raised to power x plus 4 equal to 0. We just rearrange this in this form. Okay. Our next duty is to represent 4 raised to power x with another letter. I can solve it directly, but so that you can see clearly that this is a quadratic equation, we need to do that representation. Alright, so this will become, let 4 raised to power x become p. Now what this will imply is that we have p squared minus what? 5p plus 4 equal to 0. Okay, so at the end of the day, I told you this is a quadratic equation. So you should just know the answer of this quadratic equation without solving it. Just get the two factors that will replace this minus 5. And what are they? Minus 4 and 1. Sorry, minus 4 minus 1. Once you have gotten the two factors, reverse the sign. Okay, that will give you 4 and 1. Because the quotient of p squared is already 1, so you don't need to divide by 8. So that's your answer. But just for us to verify, we can solve it. So what do you have? P squared minus 4p minus p plus 4 equal to 0. So what do we have? P is common. We are factorizing now. P minus 4. There was common here. 1. Okay. Minus 1. Then I have p minus 4 equal to 0. So what's common here? We have p minus 4 is common. What will be left here? P, and what's left here? Minus 1. Then I can close this up. The result of this is equal to 0. So if the product of these two gives us 0, definitely one of them is 0, or the two of them. So I can say from here that p, it implies that p minus 4 is equal to 0, or p minus 1 equal to 0, so that p becomes what? 4, or p becomes 1. If you go for these two, oh, we are fortunate that they did not use these two as any of the options. We are fortunate that these two are not used as any of the options. So that means we can recall that 4 raised to power x equal to what? P. So that when p is equal to 4, what can we say? It implies that 4 raised to power x becomes 4. And what is the index of 4 here? It's 1. So that I can infer that my x will be 1 because the bases are the same. Not 4 cancel 4. You understand? When p equal to 1, then I can also infer that 4 raised to power x equal to 1. Is there any way I can express 1 as an index notation to base 4? Yes. Because I do know that anything raised to power 0 is 1, provided that thing is not 0. You get it? So that means that I can write this as 4 raised to power x is 4 raised to power 0. Okay, so that from here I can say that therefore x will be 0. So I have two values. Either x is 0 or is 1. Which of the option? Option B. Do you see that now? It's as easy as ABC. So question 4 of that same year was set on indices now. Alright, so solution. I will just tell you that if you are conversant with your WAEC past question and your JAMB past question, you will realize that some of these questions are just repeated, or they just adjust some of those questions, okay? But it's the same approach. Alright, that means that if you can't access any institution's post-UTME past question, you need not to worry yourself. Alright, you can make use of your WAEC and your JAMB past question to prepare, and you will still be able to do well, God helping you. Alright, okay, so now we have to simplify this, and the results 3/4 2 raised to power 0. Now what will this give us? 2 raised to minus 3 is the same thing as what? 1/2 raised to power 3. Sure you agree with me? And or better still, I can see 2 here, I can see 2 here. I wanted to do it individually, but I'm saying that it looks like I can rewrite all of them in terms of base 2. So I'm thinking, then let me write it this way. Let me maintain it like this, so that this one will be same thing as 2 raised to power 4 all raised to power 3/4 times 2 raised to power 0 is 1. So I can ignore that one or throw it away. So this will give me 2 raised to power minus 3 times, I won't bother myself with this one again. So this will give me 2 raised to power what? 3. I don't have to write it to save time. I know that this 4 will terminate this 4 because these two indices will multiply. So at the end of the day, I have this. So and according to the rule, what will this one give us? 2 raised to power minus 3 plus 3. Take one base, add the powers. And what will this give us? 2 raised to power what? 0, because minus 3 plus 3 is what? 0, not minus 6. So at the end of the day, what's 2 raised to power 0? 1. Oh, I'm sorry, I didn't write the option. Option A is 0, option B is 1, option C is 2, option D is 1/2. And you will agree with me that that's option B. I hope that's clear. So we have this. If this will give us the way to find x. So how do we do it? It's the same approach. All we just need to do is look for a way to express all of them to the same base, and we apply our law of indices. So solution. So this is same thing as 27 raised to power x plus 2 divided by 9 raised to power x plus 1 equal to 3 raised to power 2x. Alright, I can rewrite this as 3 raised to power 3, and I know that this 3, okay, let me do it this way. I have x plus 2, but because it is post-jam and you have to be fast, you may not need to necessarily be putting this bracket. You already know that this power will multiply this power. Okay, so permit me to do it that way to save that time. It's just because I want you to understand. Now that means I can write 3 raised to power 3, then that 3 will multiply this other one. 3 multiplied by x plus 2. Then this divide, I have this is going to be 3 raised to power 2, and it will multiply this x plus 1. Then this will be equal to what? 3 raised to power 2x. Are you getting it? From the law of indices, because of this division sign, what will happen to the powers of this? Take 1 and subtract the power. And because of this equality sign, what will you do to the power? You equate them. So to save time, instead of saying, oh yeah, this one, subtract this one, when you finish, you now equate. Don't waste time. You should know that from here, this minus this equal to 2x. That's how to save time. Then you quickly solve for x. But let's solve it step by step now. But I just showed you that because to save your time. So from here, I can have 3 raised to power what? 3, I'm opening the bracket, x plus what? 6. Because of this division sign, I'm subtracting. I'm opening the bracket now, but I will introduce the bigger brackets. So the product of this will be 2 times x is 2x. 2 times 1 is plus 2. So this minus sign is because of this division sign, since we have the same base. This will be equal to what? 3 raised to power 2x. And the result of this will become 3 raised to power 3x plus 6 minus 2x minus 2. The minus sign is being used to open up the brackets. So I have 3 raised to power 2x. So this will give us what? Actually, like I said, I don't have to be repeating it. Just pick all of these, equate them, but no problem. We have 3 raised to power 3x minus 2x is x. Then 6 minus 2 is 4. That's plus 4. This will be equal to 3 raised to power 2x. So if the bases are the same, what can you infer? We can imply that what? Our powers are the same. X plus 4 equal to 2x. So I'm to collect like term. So I'm going to have what? 4 here equal to what? 2x minus what? Minus x. So that 4 becomes what? X. Therefore, our x is 4. Which of the option? Option B. Okay, if you like, you can bring minus 2. You can bring 2x here so that you have x minus 2x. And take 4 to the other side, you have minus 4. Your result will be minus x equal to minus 4. And you can multiply both sides by minus 1 or divide both sides by minus 1. You will still get the same result. Okay? Alright. So that is for Lautech. Okay, we're asked to evaluate. We're asked to evaluate 243 over 32 all raised to power minus 1 over 5 times 2 raised to power minus 2. Okay? Alright. So option A, we have 3. Option B, we have 6. Option C, we have 1 over 6. Option D, we have 1 over 3. So what do we do? Solution. 243 over 32 So now from footer, this particular question does not take you time to solve. Okay, just remember when you have a fractional base and a negative index, what would that give you? Remember that x over y raised to power minus n. Instead of wasting time to say 1 over, don't waste your time. That negative sign indicates the reciprocal of the base, which means you have y over x. Then all raised to power n, the negative sign is gone. Instead of saying 1 over, you will be complicating matter, though you will still get the same result. Alright? So which means that if I give you x over y raised to power minus 1, it's just same thing as what? Y over x. Because everything, all this one raised to power 1 will still be the same thing. Okay? So the same way here. So this nonsense here is the same thing as you can invert it to have 32 over 243 raised to power 1 over 5. Then we have times, this one is same thing as what? 1 over 2 raised to power 2. Okay, you remember that when you have x raised to power minus n, you have 1 over x raised to power n. Don't make the mistake to think that I put 1 here because of this negative sign. It means 1 over, or let me come from this angle. X raised to power minus 1, you now have 1 over x. No, okay, minus 1, this one here is not this one. They are not the same thing. I want you to take note. This negative sign indicates the reciprocal of the base. The base here is x. Alright, and x is a rational number. I can write it as what? X over 1. Do you know that? Now, this one is this one you are seeing here, because the reciprocal of this is 1 over x. And which is this? Now, all raised to power, this one is this. But because this one, 1 over x raised to power, 1 over x raised to power 1 will give us this 1 over x. It now looks as if it is this one that is this. They are not the same thing. Are you getting it now? That means that this one came from the denominator of x, which is invisible. Sure you understand it? The same way here now. I cannot say 1 over this one here, this one you are seeing here came from the what? Because if you are saying that this one is this, then that means this one should have been n over, you understand now? So it is not, this one is not the same thing. So this negative sign implies the reciprocal of the base, so that this would have become this, and I know that 1 raised to power n in this case now will be 1 over x raised to power n. So you understand how we arrive at that. Now you can still do this directly. I just took this step to remove this negative sign, so that you have, then this one is this, so that at the end of the day I know that this is same thing as 2 raised to power 5, and this is same thing as 3 raised to power 5. Okay, all raised to power 1 over 5 times 1 over 4. So the result of this, I can take them to the same power. I have 2 over 3 all raised to power 5. Okay, it will multiply this one 1 over 5. Then I have times 1 over 4. So this will give me 2 over 3 times 1 over 4, because this will terminate this. So 2 here 1, 2 in 4 is 2. What do I have? 1 over 6. Which of the option? Option C. If you are good at taking roots, do you know that this thing from here means 5th root of this? So if you take the 5th root of 32 over 243, you will just directly get 2 over 3. If you don't want to go through all this process, you get the same result. I hope that's clear. Okay, all right. So this is question 8 of that same year, 2014. So we are to find, given that log 2 is 0.3010, log 7 is 0.8451, we are asked to evaluate log 224. It's an example of common logarithm, because this is logarithm to base 10. Alright? So our duty is to look for a way to rewrite this logarithm of 224 in terms of log 2 and log 7. Otherwise, we may not be able to get our direct answer. Okay, so solution. Log 224. Don't forget, just to reiterate, the reason they gave us this and this, log 2 and log 7, is because they know that you can rewrite log 224 in terms of log 2 and log 7. Do you understand that now? So that means, now look at this, 224. How can I rewrite this in terms of this? Look at what I want to do. 224. If I divide this by 2, okay, what will I see? I will have 1. The quotient is going to be 1, 1, and what? And 2. That shows that 224 is same thing as 2 times 1, 1, 2. If I divide this one 2 by 2 again, what would that give me? 2 in 11 is 5, remaining 10. That's 10, remaining 1. In 12 is 6. That shows that 1, 1, 2 is same thing as 2 times what? 56. That shows that 2 times 2 times 56 is actually what? 224. What can go again? I can write this 56 as 8 times 7. Do you agree? So that shows that I can now have 2 times 2 times 8 times 7 will give me 224. That's what it means. Because I've already split this 56 into what? 8 times 7. Do you understand? So now, if I multiply these together, this is same thing as 2 raised to power 2, and this is same thing as what? 2 raised to power 3. That means 2 raised to power 2 times 2 raised to power 3 is same thing as 2 raised to power 5, which is 32. That implies that I can rewrite this log 224 as log 7 multiplied by 32. Do you see that now? So rewriting this now, it means I can now write log 7 plus log 32 from the law of Logarithm. That's what gave me this. Because 7 times 2 is 14, 4 carry 1, 7 times 3 is 21 plus 1, 22. So now I can now write log 7, I already see log 7 now. Then plus 32 is same thing as what? 2 raised to power 5. So this is same thing as log 7 plus what? This 5 can come behind, then you have 5 log 2 from the law of logarithm, so that I can now insert the values. Log 7 is 0.8451 plus 5 times 0.3010. This 0.8451 plus 5 times 0050, then 5 and 1, 1.5050. 5 times 0 is 0, 5 times 1 is 5, 5 times 0 is 0, 5 times 3 15, 5 carry 1, 5 times 0 1 plus 1. So the addition of this will give us what? 0 plus 1 is 1, 5 plus 5 is 10, 0 carry 1, 0 plus 4 plus 1, that's 5, then 5 plus 8, that is 13, 3 carry 1, 1 plus 0, that's 1 plus that 1, that's 2. 2.3501. Which option? Option B. Do you see that now? It's as easy as that. Now, that's 2010-11. So question 1. It says simplify. Simplify 8 raised to power 1 over 2 divided by 8 raised to power 1 over 6. So look at this now. Solution. Okay, the options. Alright, so from Federal Poly, the 2010-2011 question 1, we have to simplify this. It's very simple. Alright, the question is so easy. So we have 8 raised to power 1 over 2 divided by 8 raised to power 1 over 6. So we just apply the indices. 8 raised to power 1 over 2 minus 1 over 6. It's as simple as that. And this is going to be 8 raised to power. What's the LCM? Yeah, that's 6. 2 is 6 is 3. 3 times 1 is 3. Minus 6 is 6 is 1. 1 times 1. 1. So this will give me 8 raised to power 2 over 6. Which same thing as 8 raised to power 1 over 3. Because 2 can go here 1. 2 is 6, 3. And this 8 is same thing as 2 raised to power 3. Because of this power, I multiply by 8. So this will terminate this. What do I have? 2. Which option? Option B. I need to let you know that since most of institutions are taking CBT, most of their questions are not the ones that will require lengthy steps. Alright, that's why you need several questions. See all the different approaches that can be used, and it will hasten your ability to think fast when you are in an examination condition. I hope that's clear. Alright. Question number 2 of the same year is on logarithm. Now, it says if tó bá jẹ́ wípé log 81 base x is equal to 4, find x. How you see this question? They don't have question now. I even thought it's very difficult. Maybe you to see that it's very simple. Alright, solution. So log 81 base x equal to 4. We'll just convert this to indices expression or equation. So this will become 81 will become x raised to power 4. You remember, if log a base b is equal to c, what does that imply? It implies that a is equal to b raised to power c. This will just carry this the same way. So my duty is to look for a way to rewrite 81 in an index notation such that the power is going to be 4, and I know that that's going to be 3 raised to power 4. So what do you observe in this equation? The powers are the same. Then I can infer that the basis too will be the same. That means 3 will be equal to x. So that what? X is 3. It's as simple as that.